Hello and welcome to my presentation on the fourth lab. Forgive the cell phone usage. I usually record this on my desktop, and for some reason my laptop can't deal with recording audio, so this is the best I can do. As a brief introduction, this lab examines the relationship between distance from the magnet and the overall field strength at that position. And the relevant equations are on the right-hand side. I used the parallel axis one to determine what the dipole moment actually was. The system is the magnet and the magnetometer, and the surroundings are the Earth. The initial conditions are that there was no local magnetic field because we canceled it out. And I guess the brief introduction to the results is just that the magnetic dipole moment was 2.97-ish. And also just that we were able to model it in a way that was predictive of the reality. Here's the details of the experiment. I won't bore you with it. You know what we did. The right side is our spreadsheet, including all of our numbers. As you can see, we got that -2-ish slope that we were expecting to get. And I used the first average value and the average distance in that second to the bottom area for finding the dipole moment. Here's my code. As you can see, we get that dipole-ish shape that we expected, with much greater magnitudes closer. Can kind of just barely see this little guy up there, very far away. And you can also see my code for finding the magnetic field here and how I structured my arrows. And I made this distance number a little more than the dperp number, just because it would dwarf it if it were smaller. There's not much to discuss here. I mean, we're basically taking a device that uses code to interpret a magnetic field data point, recording that and putting it back into a program that interprets magnetic field data. So it makes a lot of sense that it would look consistent, and yeah, it does. It looks consistent. But the sources of error would include imprecise tools. I mean, it really was just like a cell phone app. I don't expect it to be like a rigorously tested, reliable measuring device. There was a lot of, small but compounding changes in the measuring setup, bumping the phone, bumping the meter stick. Also, there was just a lot of electromagnetic interference in that room because there were a lot of computers. It's a giant building full of computers. You can't expect it to be perfectly accurate everywhere on Earth. So for the what if questions, what if the Earth's magnetic field weren't accounted for? And really, I mean, that would just mean that there'd be an extra bit of electromagnetic field to worry about in that direction. So there'd be something either compounding with or canceling out our measurements in the x direction, and I think it would also affect the y direction. And it would mean that relatively the arrows would remain somewhat consistent, but their sizes would be all wrong. And we wouldn't be able to come up with an accurate magnetic dipole moment. And the other question is, if we repeated it with two magnets stacked end to end, how would it differ? And I mean, about as you'd expect. I don't think it would quite double the magnetic field strength. But I mean, fundamentally, magnetic fields are just caused by magnetic material creating a field in space around it. So when you have more magnetic material in a small amount of space, you're going to have a stronger field. But since you're not quite able to pack all of that material into the exact same volume as the original magnet, it's not going to exactly double, I think. It's going to do something between nothing at all and doubling completely. I would err towards doubling because you're adding a lot of mass without a lot of volume. Anyways, that's about it. Thank you very much.